So, good morning, everybody. Today is December 12th, 2024, Business Intelligence lecture. And we will talk today about machine learning method, ML, called support vector machines. Okay. Or in short, SVM. Okay, so this is the method we use today. We will learn today and in this lecture. So the goal of support vector machines is to separate the space in regions. Okay, so based on the training data, data set, we find with support vector machines the optimal separating line if we are in 2D, or separating plane if we are in 3D, or the separating hyperplane if we do it in more than 3D. The problem with more than 3D is that we cannot paint it, okay? That separates the space in regions. As such, is therefore this algorithm is a clustering algorithm, okay? SVM is therefore a clustering algorithm we have seen a clustering algorithm like Cummings cluster that cluster the points but not cluster the space. So as an example, we can see this. Imagine you have a map of coordinates, let's say in 2D. And you have a bunch of customers located in this area. Customers, let's say the lilac and then blue customers in this area, and then green customers. Okay, so and you want to separate the areas of the city. This is the city, let's say. This is the space, city. You want to separate the areas of the city so that you get your delivery service in place. So what this algorithm does is it finds you the best separating lines for your given space. Okay, so it gives you these lines, the equations of these lines, which would be something like y equals to mx plus b. Okay, so all these equations, mi, bi, all these equations would be then given by the algorithm. All right, so that we are able to say, okay, this area, this lilac area is defined, and then the blue area is defined in such a way that when you do that, when you do that, your city, let's say it's divided, and when you get a new point, you have a new delivery, let's say it's here, okay, and you know it needs to belong to the class of the green point, so the green team will deliver. That's why we say that we're clustering, but we're clustering the space, and we're not clustering the points as we would do with k-means clustering. Okay? Does it make sense what I'm saying? Any questions? Thumbs up, thumbs down. So there are many applications on this. Of course, this is just a little example with two dimensions, but you can get like 20 dimensions, and SVM is very effective and very fast, so it can help you cluster customers and a lot of things. Okay, so we're talking about data sets. So one important thing here is we need training data, to perform SVM. This means we talk about a supervised learning algorithm. It's a supervised algorithm. Okay. We also say that we find the optimal separating separating line or hyperline or hyper plane. In general, it's a hyperplane. Hyperplane in 2D is a line. We say we find the optimal separating line because we find the line with maximum distance to the points to the training points. Okay. So the distance to the training points is distance. This can be computed and measured, and this line here is the line with the maximum distance to all training points. Okay. All right. So let's look at an example with some data. To visualize, and let's see, I have here the height and the weight of the students in the class. Okay. And I take this data and I cluster that, or we cluster that based on sex. Okay. So let's say we've got here ten data points. 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10. So sorry, it takes a little bit of time, but I think it's prettier if it's neat and tidy. So I prefer to do it like this. It's also better for learning. So anyway, so let's get the data set up. The first data point is 155.50. which would yield into something like, would yield into something, into some graphic like this. I'll paint it while I get the data. So X and Y. So 155, 165, 175, 185, 195, and then wait, my screen froze, sorry, I don't know why. Need to jump out and jump in again. Okay, my iPad just froze. I need to restart it. Sorry about that. Can you hear me still? Yeah, sorry. My iPad froze. I don't know why. I need to restart it. I hope it works that. So just 1 second. Okay, it's not connecting. No. Okay, I'm in again. Okay, I'm sorry. I'm in again. I was setting up the axis here, so I guess nothing was lost. 50, 60, 70, 80, and 90 kilo. Okay, so the first data set is somewhere here. Let me paint the points of the women. So this is a woman in pink. Okay, so the second data set is 160 and 60 kilos, so somewhere here. The third point is 158, 68, somewhere here, no, somewhere here. Okay, the next point is going to be 150 and 58, so 150 and 58, somewhere there. And 100, there's also a woman, and 170 and 55. Also 170 and 55 somewhere here. Okay, so these are all the points. They're clustered. We have women there. Let's get the man. 165 and 90 kilos. 165 and 90, somewhere around here. Then 175 and 85. So this is a man and a man. 175 and 85. And then again 180, 88, another man, 180, 88. Somewhere there. 190 and 75. 190 and 75 and 185 and 72. Okay, so you see, you can see that, I guess it's intuitive that there is a cluster here, there is a cluster here, and we could, we could easily cluster these points by using Cummings clustering and say, well, yeah, we know that these are the clusters, and we can find two clusters, and that's okay. And if we find a new point, we can do that already. But now we want to cluster the space, okay? So, and the way to do it is, there are several ways to do it, but I'm gonna just look at the easiest, okay? So you draw one possible. And this is not the best way, but it's the easiest way to explain it, and I guess for our level it's okay. So this line, which we will call, let's say, L1, it's a possible, this is a possible, it's not the best, but it's a possible separating line. Right, because it just all the points in let's say in light rosa are on one side, and all the points on blue are on the other. So it's a possible separating line. It's not the best line because it does not have the optimum distance to the points, but it's a good separating line. It would help. So the same thing with this, okay? This line takes all the blue points in one side and all the light rosa points in the other, right? So this is also a possible, we call that L2, okay? Both are possible separating lines. So you cool with that? Yeah. Yeah, if we have a woman, let's say here, okay, yeah, so we would have a separating line that would be like this. Leaving all the rosa points in one side and all the blue points on the other. Okay? It depends, man. I'm just giving you an example. If of course if you have one man here, then you need to do something different. But let me just go step by step, okay? Yeah. If you have one man here, then you need to do a tricky thing, okay? So like this, okay? But this is then not so easy to calculate, and we will not look into that as of now, okay? It is possible, but we are doing here the baby steps, okay? You need to understand that this is just, let's say, an introductory thing. If you want to go deeper, contact me offline and I'll give you more. So anyway, so the issue is that if we want to have the maximum distance to the training points, then the best line, it happens that the best line goes like this, okay? So this is the line that we're looking for. Okay, it goes through the points 0, 90 and 190, 0. And it also goes through this little point there where you see, interestingly enough, all three lines go through. Okay, so the best separating line y equal mx plus b goes through the points 190, 0 and 0, 190. Okay. No, it should not be 90 degrees. It's just depends on the scale, but no. One thing you need to know is the equation of a line that goes through 2 points. So this you need to know. I paint you my little H4 Ausrufezeichen here. Here the equation of a line going through 2 points x1, y1 and x2, y2 is like this. All right. So this you need to know in order to solve this algorithm. So let me just paint it. This is the line X, Y. And the line goes through points. Okay. So that's the equation of that line. And also, second thing that is important, the distance between a point x1, y1 and the line y equal mx plus b is given by the equation absolute value of mx1 plus y1 plus b divided by m squared plus 1. Okay, so this is also something that you need to remember. This is basic algebra. It's just like an application of Pythagoras, but some people don't have it in their memory. So that's why I write it. It's a kind reminder. So we have the distance right there, and the equation of the distance between this line and this point being this x1, y1. This is the distance. If this is a square, if this is a square angle. Okay. All right. So with these two things, we can hit the trail. Any questions? We are trying to separate this space. We try to find the red line given the data above, and that's what we do with SVM. Okay. Of course, we can do it with more than 2 classes. We can do it with more than 2 dimensions, but this is not what we do here because we are just giving the baby steps. If you are interested in more, contact me offline and I will give you more material. Okay? Anyway, let's do our first calculations, our first example. Given two data classes, red and blue, please perform all necessary calculations to A. Find the optimal separating line y equal mx plus b to separate the two classes. B calculate the distance between the points closest to the line, and C, identify the so-called support vectors, okay, which is something that I will explain later, and that's why we call it this thing support vector machine. Okay, so this is an algorithm. So the first step is to get the data. We have red data, which is class A. We have our points A1, 1, 1, A2, 2, 3, A3, 3, 2. And we have our blue data, which is class B, which is B1, 5, 3, B2, 6, 2, B3, 6, 4. All right. These are the data. So our first step is to draw the data. This is something that you don't need to do in real life later on, but I recommend that we do it now to understand the algorithm better. So to get the data painted, we go and paint this. So here we have 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Okay, do one more. And then we paint the red dots and 1, 1, 2, 3, and 3, 2. So these are the red dots, and the blue dots are 5, 3, 6, 2, and 6, 4. So somewhere there. All right. So these data are like B1, B3, B2, and then A1, A2, and A3. All right, so that's the first step. That's an easy one. So the second step Step 2 is calculate the point. We painted it before here, where the two gray lines interconnect. We know that our separating line goes through there. So the point where L1 and L2 intersect. So L1, L8, and L2, I'll paint them here roughly. So we take L1 goes through A2 and B2. This is L1. And L2 goes through, let's say, A3 and B1, I guess. I guess my painting is not so good. 3, 5, 3, and then 6, 4. B3 should be a little bit lower. So B3 is around here. It should be B1, the one we're talking about. So let's paint it here. So this is L2. Now please pay attention, okay? I'll do it slowly, but you need to pay attention. So the line that goes through A2 and B2, L1, is, the equation is y minus, so A2 is the point 2, 3. And B2 is the point 6, 2. So the equation of that line is y minus 3. This 3 is, let's say, this 3, okay, divided by x minus 2. And this 2 is not these two, not that one, is this one, okay, equals 2 minus 3, where this 2 now is this, and the 3 is the 3 we had, divided by 6 minus 2, 6 minus 2, the lilac one. Okay, so be careful. This means that y equals 3 minus 1 divided by 4, x minus 2. Just putting the things together, okay? And then the second goes through A3, which is 3, 2, and B1, which is 5, 3. So it's y minus 2 divided by x minus 3 equal 3 minus 2 divided by 5 minus 3. So this is y equals 2 plus 1 divided by 2 x minus 3. So those are the two equations where they cross in this point. Ja, klar, ja. Also y minus 2 geteilt durch x minus 3. 3 minus 1 ist 1. 5 minus 3 ist 2. Dann y minus 2 ist gleich 1 geteilt durch 2, x minus 3. Und dann y ist gleich 2 plus 1 geteilt durch 2x minus 3. Ja. More questions? Okay, so we have equation 1 and equation 2. If we say 1 minus 2, then we have y minus y is 0. 3 minus 1 divided by 4, x minus 2. Minus 2 minus 1 divided by 2, x minus 3. So 0 equals 1. Minus 1 divided by 4x plus 1 divided by 2 minus 2 minus 1 divided by 2x plus 3 divided by 2. So, and this is the point x0, okay, the point we're looking for. As a result, we get that x0 equals 4. And because x0 equals 4, y0 equals 3 minus 1 divided by 4, 4 minus 2, inputting into the first equation. So y0 is 2.5. Okay. So we know that our line goes through the point x0, y0 equal 4, 2.5. As a result, we know that y, because we know that this is true. So this is our first equation. We need two equations to know m and b. And but this is our first one. Okay. Any questions? And how to get to this? So you see a little bit approximately this point is 4 and 2.5. Okay. So this pretty accurate. So now step number 3. Calculate the distance between the separating line and the two closest points. Okay, so in reality we would need to calculate all the points, but we only take the closest points, which are A3 and B1. You can see that from the graphic, that's why we paint it. Okay, so this is somehow the separating distance, the distance with the best possible distance to the points is a little bit like this. And the closest points are A3 and B1 or A3 and B2, okay, depending how we put it. It doesn't really matter. We can take we take just 2 points of each group, calculate the distance, and the distance should be equal. Okay, so as I said, this is not the way this is calculated. This needs to be calculated with gradient descent and stuff, but this is the easiest, so that's why I do it like this for this level. Okay, so the distance between the line and the point A3, remember, is 3, 2, is m times 3 plus 2 plus b in absolute value divided by square root of m squared plus 1. And the distance between L and B1 should be, B1 is 5, 3. M times 5 plus 3 plus b divided by square root of m squared plus 1. Both distances should be the same. Both distances should be equal. To ensure maximum distance. And as a result, we get our second equation, because m 3 times m plus b plus 2 plus b equals m times 5 plus 3 plus b. b scores itself out, and then we get that m equals minus 0.5. This is equation number 4. So, and as a result, if we insert that into equation number 3, we get that b equals 0.5. So our separating line is y equal minus 0.5 x plus 0.5. Okay. So this solves the first question. What is your separating line? The second question is, what is the distance between the line and the 2 points? Well, this is a piece of cake. This is absolute value of 3 times minus 0.5 plus 2 plus 0.5 divided by square root of minus 0.5 square plus 1 equals 1 divided by square root of 5 divided by 4, which is 2 divided by square root of 5, which is 2 divided by 5 square root of 5, which is somewhere 0.894. Okay, so this is the second answer to the question. B, and then the support vectors are just the points A3, 3, 2, and B1, which is 5, 3. So the reason why you call this support vectors is because they support, these points support the calculation of the, let me paint a little drawing more. When we talk about a point, in reality, we're talking about a vector and not about a point. This vector goes from the origin, okay? So let's say we have here the point here, say is 3, 2. The coordinates 3, 2 refer to the origin 0, 0, right? So this point A, we say it's the point 3, 2, but in reality, this point is 3 minus 0, 2 minus 0. It's a vector, okay? That goes from the origin to the point. Do you reckon that? Hello? Yeah, so that's why we're talking about support vectors here, okay? We say 2 points are the support vectors. There's the closest points to our line, okay? So any questions on the exercise? What is the third step? No, where exactly? Yeah. Where are you lost? Where exactly where? Where? Here? Step 3? Yeah, what we did is we said, okay, the distance between the 2 points A3 and B1 needs to be the same to the line, okay? So we're looking for the equation of this line. So the distance between A3 and B1 needs to be the same. So what is the distance between a line and a point? It's given by this equation. Okay? So mx1 plus y1 plus b in absolute value divided by the square root of m squared plus 1. So what I did is, because we already know the points A3 and B1, which is the point A3 is 3, 2. Okay, and this is the 0.53. This goes here, this goes here, and this 5 goes here, and this 3 goes here. Okay, and these two equations need to be the same because the distance should be the same. So I take this part, take it there, this part, take it there. Okay, and then I just simplify. B goes away, and then 5m minus 3m is 2m, and 2 minus 3 is minus 1, so minus 1 divided by 2 is minus 0.5. So we have m. And then we insert m in equation 3. We put it here. Minus 0.5 times 4 is minus 2, so yeah, and so on. All right? Good, cool. Yeah, so that's basically the exercise. Actually, I'm thinking that B should not be 0.5 but 4.5. Because if m is minus 0.5, this is 2 plus 2.5 is 4.5. So this is not correct. This is 4.5. And then this is also not correct. Minus 1.5, 3, 5. So this is a 5. And then this is also wrong. Square root of 5. Okay, so this is correct. Anyway, all right, so we got this exercise done. Let's do another one to settle it. Now I will do it as it should be done in the exam by you, okay? So we have a red class. So questions. As above, okay? So we have a red class, A. So we have A1, 0, 0, A2, 2, 0, A3, 0, 2, and we have a blue class, B, B1, 1, 4, B2, 4, 1, B3, 4, 4. So the first thing we do is calculate the lines. Y minus 1 divided by x minus 4 equals 2 minus 1 divided by 0 minus 4. Of course, until you get to this level, you need to do some practice, okay? But this is the way I picture it for the exam for you. Line 2 is equal y minus 0 divided by x minus 2 equals 4 minus 0 divided by 1 minus 2. Then this is 0 minus 4 times x minus 2. If you subtract both, you get 0 equal 1 minus 1 divided by 4, x minus 4. plus 4 times x minus 2 in 0. So forwarding it more, you get 0 equal 1 minus 1 divided by 4x0 plus 1 plus 4x0 minus 8. This yields x0 equal 1.6, and this yields, if we put that into the first equation, y0 equal 1.6. So our point is x0, y0, 1.6, comma 1.6. As a result, our equation looks like this: 1.6 equal m times 1.6 plus b. This is our third equation. The distance between A3 and the line that we're looking for is m times 0 plus 2 plus b divided by square root of m squared plus 1. And the distance between L and B2 equals m times 4 plus 1 plus b, m squared plus 1. So as a result, you get that m times 0 plus 2 plus b equals m times 4 plus 1 plus b. You cut, so you get that m equals 0.25. If you plug that into 3, you get that b equals 1.2. So the equation that we're looking for is 0.25x plus b. That's the first answer. The distance that we're looking for, A3, equals 2 plus 1.2 in absolute value divided by 0.25 squared plus 1. This equals 3.0117. So that's the second question, and the support vectors are A3 and B2. Okay, so this exercise, I just made it in less than 5 minutes. It's like 20 points in the exam would be, okay? And you would get like, I don't know, I think 15 minutes to perform it in the exam. Okay, so 3 times more than myself, which I think is fair. All right. You can go on and check the solution and paint the points and stuff like that. I just did it fast on purpose so that you see what speed you need to attain for the exam. Okay? Questions? I do know, but I cannot tell. I'm sorry. I want to tell you, but they don't let me. And I cannot do it if they don't let me. I don't want to. Yeah, I'm sorry. Okay. It's going to be, well, I will explain everything next week, so you don't need to worry. Just start with the content as soon as possible. Okay, it will not be difficult if you do what we did in class and you can do it fast. Shouldn't worry too much. So I'm not going to ask algorithms that you don't know. Okay, so but about the exam we will talk next week in the class. So please, please, please make sure you come, okay? Make the room full. If you need to take some holiday for that, or some extra free hours from your job or something, just do it. Just it will pay off. All right. So I hope you enjoyed. I hope I'll see you on Wednesday on the class, the brain hacking thing. I think that might be interesting for you guys.